Now, this problem of having multiple dimensions in your data set is commonly referred as the curse of dimensionality. And we call it a curse simply because it is actually a curse for a large number of machine learning algorithms. They simply cannot perform in the context of a very high number of dimensions. Hence, there are a number of algorithms that we can use to reduce this dimensionality. One of those algorithms is PCA, which stands for Principal Component Analysis. And PCA is basically a linear technique that you use, which is based on exact mathematical calculation. Hence, it is rather considered to be more like a statistical approach than a purely machine learning approach. TSNE, which stands for T-distributed stochastic neighboring entities, I know, like the name sounds daunting, but in its essence, this is nothing more than a probabilistic approach for reducing dimensionality. What makes TSNE interesting is the fact that the target number of dimensions with TSNE is typically 2 or 3, which means that TSNE is used a lot for visualizing your data. Suppose you have a data set with a very large number of dimensions. Understanding it visually is impossible for the human brain unless you have 2 or 3 dimensions. So you will typically use TSNE to get down to 2 dimensions, and then you will plot that particular data set in the form of a scatter plot, and all sorts of interesting patterns of data will appear. What is very interesting with TSNE is that it has this remarkable capability of keeping close points from the multidimensional space close in the 2-dimensional space. That's why it is very interesting and very useful. Feature embedding is another class of dimensionality reduction techniques that are based on training a separate machine learning model to encode a large number of features into smaller numbers of features. Since the result of dimensionality reduction are critical, and they are essentially some new features that appear in your data set, dimensionality reduction is commonly referred as being part of the larger family of feature engineering techniques, but they are also considered to be part of the feature learning types of techniques. So with Azure Machine Learning, we have a couple of modules that are available for these types of actions. One is the filter-based feature selection module that helps you identify the columns in your input data set that have the greatest predictive power. And then we have the permutation feature importance module, which helps you determine the best features to use in a model by actually computing a set of feature importance scores for your data set.